Great.
Yes.
So welcome everybody to the next session of our Straxferno course. So we have now entered the first circle. The course has really started. Uh, we're going to talk about high-level processing today. So the idea is that I'll give first a little intro. I actually have a homework assignment for you for next week or next weeks. And I'll give a very short outline of the high-level processing plugins. Then we'll go, since we now have actual code that we're reviewing in this session, we'll go through the two files that were on the reading list, rather than going through the individual study questions. Since last time we essentially only discussed those, but I especially also want questions that you had on this reading to be discussed. So we'll just go through the code and then please raise any question you have. If nobody has any questions, then I'll try to poke you with some questions. So that's the idea. Before that, let me just advertise that we now have a course repository. It's here, seen on the Straxferno. If you have anything like a solution to an exercise or some particular example that you want to share that maybe illustrates a point made in one of the sessions, then you can just upload it here. And I will upload the little intro presentations I give, and maybe if there's any interactive session or something, or solutions to an exercise, I'll put those here. But I'm not going to promise that I'll make fully worked solutions for all the exercises. The point is that you guys do it. Okay. So let's get back to presentation. So for next week, I don't have any exercises. Instead, I propose we do a homework together. And that is, so you know that we won't be able to go through all of the code in Strax, and even in this 9 session, or if you include the first one, 10 session course. So let's divide some of the algorithms among us. So the homework is to sign up for a Strax function or algorithm on this spreadsheet. So I've listed here a variety of functions that you're going to encounter either this week or next week, most of them next week as we go through the low-level processing. Here you can see where they are. So for example, this one, sort by time, that's in Strax processing, and then general.py. So you can just look it up. It will be in Strax, and then processing, and then general.py, and then you'll see sort by time over here. So this is a particularly small function. Most of these are larger, but everybody has different availability and experience. So I also indicated the difficulty here, so you can choose your own level of challenge. So you just put your name over here, and then your job is to study that function. So have a look at, for example, the docstring first. Maybe you want to skim briefly over the code. You can check where it's used. So then you can search in the Strax instruction repository. Try to see for yourself what goes in, what goes out. How is it tested? So we have unit tests in Strax. You can find those under tests here. You'll see these when you start searching for where the function is used. And then you'll find some of these tests, or none. That could also be. Maybe then you could think of a way you could test it. And then finally look at the implementation. So is there anything unusual? And then to summarize, you can choose either to add a slide to a presentation, or you can make a pull request to try to improve something about this function. So it could be as simple as adding a bit more comments on something that you found puzzling, but then you thought about it and you realized how it works. Maybe you can fix some issue that you encountered, something like this. So my suggestion is that you do this. Well, it relates mostly to things that we're going to discuss next week. So the ideal time to do it is either before next session or after that. And yeah, I hope we can feature some of these pull requests or one slide presentations next week or in the sessions after that. we're not going to, also if everybody does something, we probably won't feature all of those here, but let's see how that goes. I certainly hope we can feature a lot of them. There's a detailed description of how you can go through about this on the wiki. You've also find a little description of like, what did I mean by easy, medium, and hard, and those kind of things. Right, so is that homework clear to everyone? Any questions on it?
No.
Okay, thanks. I hope this will be useful for us. So then let me give a very brief introduction to the code we're going to walk through today. So this is the high-level processing code. So on the left, I've shown the dependency diagram of the code that you've read. So you can see event info is at the top, and peaks, which was actually not part of this reading. Well, okay. Peaks is not part of this reading. That's, of course, why the black bar is in front of it. So then you have several peak plugins, which are here in green, which make up the peak processing that you've read, and then here the event plugins that make up the event processing. And here on the right, I've shown just for all the data types in Strax for a Xenon 1-ton, 1 hour background run, how large are these files? So how large are these things on disk? So for example, here you have raw records, which we discussed last time. That was here more than 30 gigabytes per hour. Whereas at the top here, event info is only 5 megabytes. So that is a huge reduction. And that, of course, completely changes how you do analysis. For event info, unless you're dealing with months of runs or maybe many weeks or something, you can just load this data in and work with it. For raw records, you can almost never load the data in except for small pieces. You have to use the techniques we discussed last time. And what we're focusing now is somewhat higher level things over here. So most of them are like a few megabytes. And then you have here things which are maybe a couple 100 megabytes. One thing is odd though, peaks is listed as 0. So peaks is actually not stored, and we'll get to that next week because it is, you can trivially create it from 2 other data types by just merging them together. So that's why we don't store it, and just to save some disk space. Maybe we will in the future, but for now it's not stored. Okay. So just to give you an idea of these plugins.
Just one
go ahead,
question.
Mm-hmm.
So with depth and so in file, I assume that you decide some typical size of the file, and if you have too much data, you divide in multiple files. And with depth, what is it? It's just how many dependents you have from each other.
Yeah, so this is actually taken from I think an email I sent to Evan at some point. So the depth is not, and files are not so relevant here now, but you're right. So the depth is just like how far do you need to go in this tree to get at it. And number of files is how many files there are on disk to store this. And Strax will, it will automatically split it over several files if the size becomes too large. And at the very lowest depth, the file size is actually determined by the chunk size from the DAQ. That's not, you can change it, but then you have to change the chunk size that the DAQ outputs, so that you can't change that in Strax anymore. But we'll get to that, why that is next week, I think. Okay.
Yeah, sure.
Sure. Okay. So for peaks, by the way, do you guys see like these zoom features in the screen? I guess not, right? Zoom hides these. So you can just see the slide without obstructions.
Right.
Okay, good. Then I don't have to worry about that. So peaks is here at the base. That's not really part of the reading today, but it's sort of the gateway between low and high level processing. So it's good to know about it. So peaks contains the sum waveform, and it contains the per PNT hit pattern. Those are the main things. So notice it does not contain the time dependence of the PNT hit pattern. So it doesn't contain like every 10 nanosecond sample for every PNT. That is low level information that is much larger. And if we still have this here, then the data will be huge. There's also some other information, mostly things that you can only derive by going back to that data. So clearly we want to have that now in peaks because we don't want to go back to stuff below peaks after this. So things like how many saturated samples were there in the channel, so the ADC saturation. What is the tight coincidence, right? So the sort of the number of hits within a certain window, or the total amount of hits that the hit finder found. And that information can actually be lost, as we'll see next week in some cases. Daniel, you had a question.
Is this a feature that you have, or that you set the hits information to 0 if they are split, this n hits?
Is it a feature or I think it is an unfortunate fact. It is not a bug because we know that it would happen. But yeah, if there was some way to do it, then that would be great. We'll discuss it next week, but it comes down to if you split a peak, then yeah, you would have to sort of go back to the hits to find out which hits were in the left peak or in the right peak, and maybe some hit is in both peaks. So then that information is just not provided. But you still have like how many PMTs contributed to it, which is usually as good.
Because I think, so for one of the tasks, there was this task with this n hits for today, isn't it? Or did I?
Yeah, that's right. So in that case, we can look at it, but
Yes.
that's one of the exercises, yes. So you can,
So
of course,
maybe
still...
we can also chat later because I added a way to compute the number of hits because I
okay.
thought it would be part of the task.
Great. So no, I mean, the exercise here was just to make this variable available, but if you found a way to compute it in the cases where Strax currently does not, that's great. Okay. Right, so I mentioned that it's not stored on disk, but that we'll see again next time. So then there's the plugins that compute the peak properties. So you might wonder, why are there these plugins? Couldn't we just compute everything in peaks? There's basically 3 reasons that we add things here rather than in peaks. Some things are really trivial to compute, but they're useful to have as an alias and useful to load maybe in a slightly smaller file than peaks. And maybe some people want to load it as a pandas data frame. Anybody know why you can't load peaks as a pandas data frame? Maybe somebody tried.
Because there's arrays.
Exactly. There's array fields, like there's some waveform with a per PMT hit pattern, and then pandas says no, or it says something complicated. Right. So that's one reason why you would have why we have some properties computed here in peak basics, like air affection top. Of course, you can compute that trivially from the hit pattern, but it's useful to have as an alias. Second, there's things which are a bit more tricky to compute, and you want to version this separately. So here, peak positions, the reconstructed positions. Clearly, if you have a new neural net and you want to be able to remake that, the peak positions without remaking peaks and going back to the record data, because that would then maybe require downloading a lot of data. You don't want to do that. And finally, we have some properties where you need to look at other peaks. So things like time to the next or the previous peaks, or the number of nearby similar peaks. That's a little hard to do in peaks itself, where you're just looking at one peak at a time. Okay, so then there's various event plugins. So let's go from bottom to top. So here you have events, and all that does is just decide where events happen and how long they are. Basically, maybe just like very basic properties like number of peaks in it or something. Then you have event basics, which is the main event plugin, and that decides what is the main and what is the alternate S1 and S2, and stores the properties of their peaks. So that's most of the stuff that was made here in peak basics. Things like the width or the area, area affection top, those kind of things. Then there's a couple of plugins that compute other event properties based on these. So then you must have already have a main and an alternate, maybe S1 and S2. So like the position from the drift time, field distortion, and something that's new in Strax is that we also compute we estimate the energy. So G1 and G2 are some of the configuration options of Strax, and if they are set correctly, then you just have the energy available for every event. You could maybe extend that if you want to estimate, for example, the number of electrons, the number of photons corresponding to an S1 or an S2. These things are possible. And the idea is, of course, that this is nice for an analyst so that they don't have to worry about exactly how that estimate or computation was done. That if later we have some more fancy energy estimation, you can just change that plugin and the analysis based on just the high-level plugins works the same way. So there's this event info all the way at the top, which just merges everything together. That seems a little wasteful. I mean, you could just have a couple, with these plugins, you might load one or two of them, then you only load that in memory. But yeah, the event info is such a small data type that it's convenient to already merge everything together. Andre, you had a question?
Yes, I have actually a question about events. Is there a way to force event selection? For example, like based on the truth, when we generate Monte Carlo true events, and then like it's kind of confusing because I had to add a hacky way to get myself like a training patterns. But it would be kind of interesting if there is also a way to like go as down as peaks and kind of predefine event ranges there. Is there an option like that or not?
So you're asking about an option to select events based on Monte Carlo truth info, is that right?
Yes, so it can be easier used for further studies, like positional construction, because then you can isolate peaks and know where the truth is and all that stuff.
No, that is definitely something that is great to have. The way to do that is that, of course, the truth info has to come from somewhere, and you then need to match that to events or to peaks. So the way that's done, maybe you've done this already. Let me just show this to you in the presentation. Let's see, where is it? I think, yeah, here we go. So figures are taking some time to render. Did it just not render? Ah, here we go. So the way to do that is to add a little plugin on top of the big stack, right? So you have here your instructions to the waveform simulator, and then you'd have to add a plugin here on top, which matches the event info with the facts instruction, add, for example, things like matches or does not match, and then you can select based on that. I don't know of any standard plugin that does this, but I know that several people like Joran and Janju and Peter have worked with this. So it would be good to standardize such a plugin, I agree, but I don't think that currently exists, but maybe others can correct me here.
I don't think there's an actual thing. In my waveform simulator tutorial, there's sort of a way to do it. If you write a loop plugin and then you loop over the truth information and you get the peak associated to that thing. But it's kind of tricky because of the timing information with the loop plugin. So you need to basically have something starting before and ending after the other thing. So you don't really have nice contained things to loop over. So it's a bit tricky to do it correctly.
Mm-hmm.
Yes, and I've done it exactly the same way, actually, because I use it as an example.
Yeah.
And if you would have some sort of like an event defined, like Monte Carlo event defined beforehand, and then we kind of give all the pulse and so on, but they're kind of contained within one event, that would be way easier. Of course, like there are hacky ways, like you can assign different runs and so on, but it's also like not nice, I would say.
Well, you can make a Monte Carlo event plugin, which takes some time window surrounding the truth information, and they can match it to that. That would work.
Okay, I think this would be a nice thing to add. Maybe you guys can work together on this. Would be useful for many people, I think. Okay. Right. So I think that's actually all I had to say on the outline of these plugins. Are there any other questions just about this this rough outline before we go into the code? have to reposition my chair in the meantime.
Yeah, maybe just one quick question. It's Andrea
Go
speaking.
ahead.
No, just curiosity. I saw there's a event info double in some dependency I saw in the scheme structure.
Yeah.
What is the status of that?
That's right. So I don't know if Maxime is here, so he can probably give more details. Ah, you are here. Okay.
Yeah. So basically, event info double is just a plugin which will take the event info output and it will rename the field. So S1 area, alternative S1 area into S1A and S1B into S1A or S1B area. It's the purpose of this plugin is to be used for Krypton analysis, in which we are using a time ordering of the two largest peaks for S1 and for S2.
Okay, I see. Thanks.
Double stands for double scattering.
Yeah. So as you can see, this is also one of those things that are not stored on disk because it's again trivial to compute from the earlier plugins, just a renaming of fields basically. That's the idea.
Yeah, actually there is one thing which is hard to compute is a number of distinct PMT between the secondary peaks for S1 or S2 on the main. But
yeah, you're completely right, Maxime. So that's a plugin that's not shown here, but there's another one which is only required by event info double, and that plugin does take some time to compute because it goes all the way back to peaks. Okay, other questions on this this brief outline?
How long does it take to process a 1 hour run from raw records up to event info?
Then I have to pull up the performance projections we had. So this was already some time ago, but there haven't been major changes in the algorithms except maybe for the pulse filtering, but that's currently disabled. So if you want to go, so we're talking about like if you already have peaks and you want to go to post peaks, that is, I think we didn't even measure it. No, this is the time here. So it is half a minute per run in this measurement. I wouldn't be surprised if that becomes a bit longer, but order minutes for sure. If you want to go further down to lower level processing, then things take longer. So this is a Xenon 1-ton run. We don't know how long it's going to take for Xenon N-ton because we don't have the final data yet, but it should be on the order of half an hour, or a few hours at most to do the full processing for a run on one core. If you have a multi-core machine, then you should be able to do it live, and that's of course what we do at LNGS.
Okay, thanks.
Yeah. So maybe as something to keep in mind for yourself, if you're just reprocessing something, if you stick with the events things, then usually it's very quick. If you have to go anywhere below peaks, it can take a long time. And if you have to go all the way to records or raw records, then you probably shouldn't be doing that in a notebook anymore, because then you're talking about maybe waiting an hour or something. Then it's better to submit a job. But yeah, if you just want to change a simple option like so like for example the ordering of the S1s and S2s, or some threshold in how events are defined, you could completely do that in a notebook fine, unless you process like 10 months of data maybe. Well, maybe I'm exaggerating a little bit, but well, you can try it, but that's at least a rough guideline. Okay, so let's delve into the code then. So I'm opening my editor here. This is PyCharm. I'm not paid by them, but I still highly recommend it. It has all kinds of nice features. For example, if I make a typo somewhere, well, then this time it doesn't see it, but if you have something that's from a function, see where something in Strax is being called. Here end times, suppose I do this, and it says, hey, what's Strax anime? That doesn't mean anything. Strax end time it does know, and if I do Control B, I can just skip to where it is used. You can split views, etc. Maybe people already know this, but also has Vim key bindings for the edits. And it does something like this. So here it says actually, hey, there's a bit of an issue. This is actually, it says, hey, this thing is not used. We can remove it. There's also integrations with Git and the debugger, but this is not a PyCharm tutorial, it's a Strax tutorial. Okay, so let's go plugin by plugin, and then happy to hear your questions or comments.
Just before you go, so for documenting what plugins do, where do you see that happening? Like doc strings on, like this is what is being computed, and this is how it's being computed. I guess they're two different things. Like, is this something that people can take if they took notes while you were speaking? Would be useful to put in, or?
I agree. Yeah, that would be good, especially to add as a doc string. I think currently most of the plugins don't have a doc string. Some of them, like on the details of how it's done, there is some comments, but yeah, there's no documentation of that kind. It would be useful to add. I agree.
Because a doc string on the class would be interesting for just like what is being computed, and then on the compute function on how it's being computed, if there's a difference. But okay, anyway, it was just a thought looking at it.
Yeah, no, it's a good thought, Chris. Yeah, so those are completely fine pull requests if you want to. I don't mean you, Chris, but anyone else here wants to practice contributing to Strax or adding something. Of course, you're welcome to it too, Chris, but you've already contributed. So okay, so let's start with peak basics, the first one in our reading. Anybody noted down a question on peak basics? Don't all rush in at once.
Well, there's the obvious question that's just sitting there in the code. Why do negative area peaks still get a zero area fraction top instead of nan?
Yeah, that's a good question. Indeed.
That comment's been there for what, 6 months at this point, 8 months?
Maybe even more. Yeah, I guess so. The interesting thing is that somebody had the idea to put that comment in, but then didn't actually change what the code. I mean, it probably wouldn't be so hard to change, right? So you see here the M that gives you the zero area, and we could just add here area fraction top. I guess it's tilde M, right? And now we have nan. That sounds better, right? Okay. So I guess answer is I can't think of a reason. Let's change it.
If you plot a zero,
it'll... Yes.
Oh, I guess you can say it.
Okay, you have now also included the case when you have no area at all that you put in nan. I would also exclude this case, or have this as a regular case.
Okay, so if you have no area in the peak, how is the area fraction top defined? Yeah, you could put it to zero, but I guess it's not defined. So you 0 divided by 0. Do you agree, or?
Yes, fine.
Okay, good. And Chris, you mentioned something about plotting.
Oh yeah, so if you make it a nan and you plot it, it won't go anywhere in the plot. But if you have it some value, it will go somewhere. So in this case, you just have to know, you have to check how many are nans before plotting, or check the number of entries or something.
Yeah.
So it changes the functionality slightly.
Yes. So this is actually a good point, that if you change the functionality of any of the plugins, there's always one thing that you need to do, or maybe two things. Can you guys think of some?
Version number.
Very good, version number, right? If you don't do that, then the data won't be recreated. So then, yeah, Strax doesn't know that you changed anything, and then our tracking doesn't work anymore. I guess the other thing you could do is change the documentation. So I changed here the comment, and there is no docstring yet, but this might be a good thing to mention in a docstring or in a comment. There is, by the way, also the per field comments over here. So you could add, for example, here, and for peaks with non-positive area. Okay, and then maybe I do it like this so that the formatting is good again. These things are not really nice to format, as you can see, because they're like a two tuple and then something next to it. You'll see another syntax also in some other plugins. At some point I got tired of writing this, and I, for example, I think in event basics we'll see some other syntax. Right, here you see another syntax. Where it's just field name, type, and then comment. And here it is comment, field name, inside the tuple, and then the type. That's actually NumPy syntax, and the other syntax is something Strax makes.
Yes, I was also wondering, at the end they are equivalent? Because at some point I was confused which one, or each plugin you should pay attention which syntax is using for the data type.
Ideally, we'd use the same syntax all the way through Strax. And they are equivalent in the sense that Strax makes them equivalent. If you put in the new styles or the simplified style, this one, it will convert it into this one before passing it into NumPy. But we haven't yet homogenized this. It may be slightly trickier to specify. Who made this comment? I forget, probably one of you guys, that if you have an array field or something without, if you have the fields without comments, then you get into trouble, because then it expects a comment in this syntax, and if you don't give one, then it doesn't understand it. But you should always give a comment for a field, of course. Yeah. Some random field.
Can I ask a question?
Yes, go ahead.
Range 50p area.
Mm-hmm.
So in the peaks width, the size is 11. I mean the size of the area. But this range 50p area, it takes from 0 to the 5th.
Yeah. So this is actually the 6th element of the list. So it is in the middle of. Yeah, if I have only 10 fingers, so unfortunately I can't count it out of my fingers, but you would have it in the middle of the list. And what you're referring to is, so here in the data types of the peak, right? You can see that, where's the widths? Here, number of widths. So number of widths is 11, so we store 11 widths, which are the area deciles. So there is the 0th decile, which is always 0. Not really useful to store, but we do it anyway, so that if you type number 5, you get the 6th element of this 11 list, and that is the 50 percentile of the area. So it's yeah, it's a bit of off by one juggling to get it right.
I thought 6 is the middle of the area of 5.
Oh yes,
if you put 5, it won't take the 6th.
Okay, let's check. I mean, I could very well be wrong. I make these mistakes all the time. So let's check. So here I have an array of 11 elements, and if I take the 5th element, I get 5. So that looks good, right? And let's see if that's the 6th element. So, yes, so it looks like it's all right. I have 5 elements left and 5 elements right.
But
Yeah.
if you are in a square bracket, it won't count the sixth.
So if I do this, you agree with me that 5 is the 6th element of this list, right?
So
if I do this, then I get 5. So I get the 6th element of the list if I put 5.
So if you do column and
you're saying I think you're saying if you do like colon up to 5, you're not including 5. Is that your concern, Hangi?
Yeah, that's what I mean.
Okay. So that's actually a good point. So we're not doing just colon 5. So you're right. If I try that,
right.
Let's do that here. Right, I'm missing 5. So that would be bad. But what I actually have here is colon comma 5, which means that this is a 2D array in the thing, right? So I have P is here peaks. So if I do, let's actually demonstrate this in the notebook. So I have here peaks. So I have here peaks width.
Okay.
Right, so this is a 2D array.
Okay, I got you.
So if I do colon 5, right, you could also just, let's look at the 0th peak. So that's the same as the 5th width, the 6th width over here. Yeah, but you're right. This would have been an off by 1 error if I wanted to select the first 6 elements.
Also, one thing I want to ask is, so if we have this 50% of width, why do we need to compute the middle of the time? Instead, we can just use this half of the width as the middle of the time.
You're saying if we have the 50% time width, why do we need to compute the middle of the time? You mean this center time?
Yeah. So there is a compute center times peaks.
Yeah, that's right. So what this does, if you look here, center time, so that gives you the weighted center of the time. So if you compute so the midpoint of sort of the quartile, the first and third quartile, that is not necessarily at the same point at the weighted center time, nor is it necessarily at the median. For a symmetric Gaussian distribution, that would be true. All of those mean, mode, median, etc. are at 0. If you have some skewed distribution, for example, imagine if you have something with a really long tail, then the weighted center is going to be quite a bit off from the mode because of this long tail as sort of a high lever arm. So that is center time accounts for that. But if you were to look at the median area point, for instance, which we don't compute here, but we could, that would be a different central tendency measure.
Okay.
Yeah, but yeah, that's a good question. I don't know which one would be best. I don't usually use center time, but yeah, if you need it for some analysis, then it's a good point that you should see which central tendency measurement you actually want. Maybe you want maximum or mode or one of the other ones. Okay, more questions on peak basics.
I have one question. I wanted to know, so peaks basic is looping over all peaks, or did we compute everything at one time? For example, I know event basics is looping over events, but I don't know if peak basic is.
Yeah, so this is computing everything for one chunk at a time. So this is an ordinary plugin. It just gets little chunks of peaks. So these peaks here are arrays of peaks. So that's why you see all of these things with like axis equals 1, and here's a 2-dimensional array. So it is looping over chunks of peaks, not looping over individual peaks, just to make it fast. Only here in compute center times is there actually a loop over peaks, but that's enclosed in this numba just-in-time compiled thing, so that it can be done fast. If you just to do this in Python, then it would be rather slow. A Python for loop over many elements is quite slow.
Okay, thanks. And just to go back to how center time is computed. I think there is some place for improvement here, so that could be interesting to have a look at it.
Yeah, no, I agree. This is just some number function. You had some way of making it faster or simpler, or?
No, I mean, well, I just I saw that there is some, for example, looking at after pulses, comparing the observed peaks for a given after pulse compared to the expected value, you have some a shift. So maybe it's come from how the central time of the peak is computed.
Yeah.
Not really or making it faster, but maybe more realistic.
Yeah, no, that's a good point. So maybe you can add different central tendency estimates, like the median or central time with the tails cut off, something like that here, and then check those properties. Yeah, good suggestion. Okay, let's move on to our next plugin. So this is a subject that many of you are interested in, position reconstruction to peak positions. Any questions on this plugin?
I have a question.
Go ahead, Ronnie.
So it seems like the reconstruction of the position of the S2, I mean the input of the algorithm is only the total area of the PMTs, not PMT, of the selected PMTs. Yeah.
Yes, so all this algorithm uses is it depends only on peaks. So it only knows just the total area seen in the PMT, not the time distribution in the PMT. That's right.
Yeah, and it doesn't depend on the like the position of the PMTs. So which is
the position of the individual PMTs. Yeah, that's right. It doesn't depend on those either, because so this is a neural net where these things have sort of been trained in. So we don't have to separately load that and give it to the neural net. The neural net sort of implicitly knows where our PMTs are. In one of the exercises, actually, there is an exercise asking you, hey, can you make a simpler position algorithm that, for example, reconstructs things at the position of a PMT, and then you do need to put in the position of the PMTs. Yeah.
Okay.
Does anybody know why are we doing this here? Or what's odd about this?
Typically don't do it inside of a function.
Exactly. Yeah, that's typically considered bad practice, because then people don't know that it's a dependency when you look at the top of the file. You just see numpy, numba, I'm good, and then you run the code and somewhere there's import TensorFlow. Anybody have an idea of why we did it anyway?
Because we don't want it to crash on the machines where we don't have TensorFlow?
That'd be a good reason, yeah. Though I think currently we have TensorFlow on all the machines that we're running Strax on, but yeah, that'd be one reason. There's one other. It's related.
Memory.
It's slower and it takes memory. TensorFlow is a particularly big package, and if you're just loading data, then this setup function of a plugin doesn't get called. It will only call, well, it won't call anything. It'll just initialize the plugin briefly to figure out what the dependencies are, but it won't call compute and it won't call setup. So then we just do the import here. For things like NumPy, there's no point because that's used so often that we should import that anyway. But if you're depending on some very big, complicated package, that's a good idea to import here in the setup. Andre, you had another question?
No.
Okay, I saw your hand was raised. Okay, other questions on peak positions.
I have a question. How many methods for position? I mean, I see it's just one method now for position reconstruction, let's say. Just the neural network TensorFlow.
Yeah, that's right. This plugin only computes one of them. And one of the exercises is actually to add a new one, just a sort of a toy one. The only other one that we would hope to add eventually is to have some kind of pattern fit reconstruction that will minimize the likelihood. Currently, even that whole likelihood is not implemented. So we don't have, for example, a pattern goodness of fit variable that we certainly need, but it's not implemented yet.
Okay.
So how do you?
Yeah. Okay.
How do you see multiple algorithms going in? Because this is called peak positions, not peak positions multi-layer perceptron, which is what it is. So when you have like, I don't know, some convolutional thing, and then top pattern fit, and then some wacky thing that someone else made and forgot about 2 years ago, like, how do you deal with the 10 different algorithms we might collect over Xenon N10, especially in this dependency chart?
Yeah, that's a good point. So this plugin just provides peak positions. So this will be the same as if I added here provides equals peak positions. But if you add a different algorithm, it's probably not such a good idea to let it provide peak positions by default, because then you'll overwrite this one, unless that's exactly what you want. So that would be one way to go. You add your algorithms, and then if a user wants to try another peak positions algorithm, they can just replace the algorithm in their context, or they could load a context in which that has been done. So you can just register here their algorithm. In our case, it's of course already registered. So it's in processing.
But often in Xenon 1-ton and Xenon 100, I guess, we would have two different algorithms run on the same event. And this I really didn't like, but we would compare those two as a way of rejecting events. So is that possible, or do you have to actually just replace the whole event?
You can certainly do that. You can just add a new algorithm that provides new variables and load that as well. In that case, I would certainly recommend also changing this if you intend to be used by several algorithms, because otherwise, if you load both, then they overwrite each other. One way you could do this, for example, if you've got several production algorithms and you don't know which one you want to use, you have several algorithms providing, for example, X neural net, Y neural net, and then you have peak positions, which all it does is just select one and give it X, Y, so that the plugins higher up don't need to specify which position algorithm to use. That is the current situation, which is not very good, that if the algorithm changes, if the choice of algorithm changes, we have to update all of our higher level plugins.
Okay. So then you see eventually there being peak positions, which just takes an argument or configuration string, which is the name of the algorithm to use.
Yeah, I think that would work. Yeah.
Okay.
But I just thought of that now in response to your suggestion. So maybe there's other better ideas.
I was just wondering if we thought about that, because anyway, because when there might be different times in which we have multiple algorithms or multiple of these data that are provided, peak positions, or I don't know what, any of the others, that you might want to have a few different ways of trying it. And then I guess this sort of model might be nice if you do want to have two ways, especially for vetting.
Yeah, I agree.
Not sure if it's a config, but it sounds like the things we are doing with peak splitting, isn't it?
It's peak splitting. Yeah, we are merging different data together there, but we're not really choosing. So we'll get to this next week, but if you're looking in, let's go, where are we? Peaklet processing. There is here peaks. So peaks combines peaklets and merged S2s, and then it does some kind of merging of the two. This one would be simpler than that. If you have different position reconstruction algorithms and you just want to choose one,
No, I mean the peaklet splitting. There you can select the algorithm how you want to split the peaks, and I think you can specify it as a config, isn't it?
Oh yeah, that's another option. So you can implement it all in one plugin, one giant plugin, and then have it be an option to that plugin. That's how it works for peak splitting.
I think for this, there are too many people that work on position reconstruction, so they would just collide with one another.
But I think it's actually a better option because then there is no confusion what algorithm is used. So I would actually, because then it's quite straightforward. You just like add a config to that. I would actually go with config option. Just provide list of algorithms which have to be added.
You just might end up with a plugin that's like the size of the rest of Strax or Straxen, because the reconstruction algorithms can get quite complicated. But I think you'd still know which was ran, because there would be a config option saying what your choice was. So you could have, like, instead of Strax plugin, you could have Strax plugin chooser, which just grabs some data that's been provided and then renames it to be the main one.
Yeah, there's no change in how the config looks. There's always an option choosing which algorithm to do. In these two options that are being proposed, it's just which plugin takes that and how does that look. But I think this is a great thing to discuss among the position reconstruction people who will actually be working with that over the next year. Okay, any other questions on peak positions? Otherwise, there's one or two things I would like to point out. So here you can see the options here. So we'll talk about configuration in detail in a later session, but this is just to show you how configuration options are specified. So you give this decorator on top, where you say, okay, now I'm going to specify the options, and then you pass them in as a list. You give an option name, and you have to be careful here because Strax doesn't have namespaces separate for each plugin. So if you declare an option, that option can be visible to any other plugin in principle. It doesn't get it by default. The plugin would have to say that it wants it, but everything is just collected in one big dictionary. So don't name your option thresholds or something like that. That is not helpful. You also see that some options, like here, and top PMTs are repeated. So you have here, and top PMTs is taken by peak positions, and it's also taken by peak basics. The default is incorrect, as I think Daryl pointed out last time, but there's an open pull request to fix that. Well, the default is correct for Xenon 1-ton, but Xenon N-ton, the Xenon N-ton doesn't have these high-level peak positions computed yet. I'll get to your question in a moment, Annelie. Just to finish my thought here. So you can specify defaults for options like this, and you can also specify more complicated defaults. One thing I would ask you to please not do is this default by run thing. What this does is it makes a default run dependent. That is something from an old version of Strax. I used to think that was a good idea, and I realized that is actually a very bad idea, because it means that the sort of the hash, how this data type will look, will then depend on the run number, and then somebody in computing is just going to have a head explosion on their hands tracking all these different hashes. So for Xenon 1-ton, Xenon N-ton, I just want to remove all these defaults by runs. You'll see in the next session an example for the gain model, how instead you would do specification of defaults of settings per run. So don't do this default by run. Andre, you had a question.
Is there an option to add some of the options that they would kind of be not overreadable, or some sort of like giving you an horrible error if someone tries to add the same one again? Because sometimes you don't want people accidentally, because it's basically a recipe for disaster. Someone can change it and not realize.
Yeah, you get an error, or you should get an error, if somebody tries to specify an option with a different default. So if I call my thing threshold here and give it the default of 4, if another plugin has a different one, but gives the default of 10, then you get an error. But option sharing between plugins is actually a feature. You can see that here with top PMTs being useful for both. But that is an error that you should get. Sophia?
So if you do share options like that between two different plugins, do you have to specify both or hard code it, or you'll get that error? Or is there some way, just because certain things are used, if I specify early in peaks processing, the number of top PMTs is 127. Will that kind of carry through then to event processing?
So the way it should work, but I have to confess I'm a bit rusty on this, and we'll get to configuration later. The way it should work is that Strax, when you register a plugin, will check, hey, what kind of options do you have? What kind of defaults do you have? And then it compares it to plugins that are already registered and says, hey, now there's something wrong with what is registered. So the only way you can get, so you cannot get inconsistent defaults for the same option. It should throw an error. And if it doesn't do that, then we should add that.
Okay, great, thank you.
Yeah.
Maybe it's also best if we try to put these options where there are multiple calls for the same option just in the overall context options. Because then you don't have to change the number multiple times.
Yeah, so what Johan is referring to is this context.py file, which we'll get to, I think, in 2 weeks. So we have here a list of common options. Yeah, that can be useful to specify the common option here and then just leave the default empty, no default. That's certainly a way to do it for very commonly used options like number of TPC PMTs. Otherwise, you're just repeating it unnecessarily. Yeah.
Hi. So this option thing is like a quasi global variable that's only visible to the few plugins.
Yes, so this is just an annotation basically we make for the plugin saying, hey, this plugin is interested in that option. And then where the option is actually stored is in your context. So you see here context config, which stores the actual options, or rather the overrides of those options. If you just want the default, then it doesn't need to be in here. Or rather, if a plugin wants an option, but it's not here, it'll use the defaults.
Right, so I do. Okay, so how do I tell which plugin requires what? Is it dependent on which options?
Yeah, so that you can see, well, that's the purpose of these declarations. So event basics depends only on these 2 options directly.
So, so I have to go to the source.
You don't, but that is an easy way to do it. And what you can also do is to go here to show config, and then you can see here, this is actually, so for example, peak basics. Here you get all of the options that apply to peak basics directly or indirectly. So you see number of top PMTs applies to peak basics, but there are other things that are options that apply to its dependencies. So if you change that option, also peak basics will change because one of its dependencies will change. For example,
okay.
TPC, PMTs, etc.
Okay, cool, thanks.
So even if it is an option like number of TPC PMTs, you can't just use that. You need to declare that you're using that option so that Strax can keep track of what options are being used. There's no like option that applies to all plugins, because then we'd have to remake all the plugins if they change, and we can't do that because one of the plugins is the DAQ reader, which reads from the DAQ. Okay, right, so let's move on to peak proximity. So this is a bit of a different plugin. Anybody had any questions on peak proximity?
It looks like a different base plugin.
Exactly,
So you
overlap.
want to probably this is to check what happened before and after the event, no, like in Xeno 1.10.
Yes, exactly. So it's a different base class, and yeah, you're right, Matteo. What its purpose is to look before and after where things happened, so that you can compute these kind of properties, such as the number of nearby or slightly smaller peaks. That's right. Yeah. So that's actually the third base class that we've seen. We've seen loop plugins last time, plugins this time, and this is the third one, overlap window plugin. There are others, but they're rare.
Probably it will allow you also to loop in a way that you can, you are moving up and down, but I think just a little bit down. I noticed that you can select a sort of window.
Yes, exactly. So the way this overlap window plugin works is that you declare a window, and that and then Strax will make sure that you basically always have data that is that is within that window. So how does that work? Let me go to something I prepared earlier. So this is how an overlap window plugin works. If you want to read more, there's actually documentation on this. It is here in the Strax documentation, and there's a whole thing you can read. So remember that Strax, you get the data in chunks. So you get one chunk which ends at a certain time, and then you know that you have all the data that is within that time, and there's nothing sticking out or something like that. And then the next time you get a second chunk which starts where the previous one ends, you get any data that's in there. So the overlap window plugin does two things. First of all, it ensures that the stuff at the end of a chunk, you're going to see twice. So you're going to see it first just as you would normally do, but you're going to see it again this time the next chunk arrives. So that's just cached and then prepended to the next chunk. That's the first thing it does. The second thing it does is it does something to your outputs. So if you output stuff that enters into this window, it will discard it. And same the next time if you enter into this stuff to the left of this window. So this is just to ensure that even though you see things twice, you only output in every time range once. And the part we keep is the part where there is indeed a window of data on both sides. We throw away these things that are computed at the end of the window, which might be suspect. For example, if I compute the time to the next peak, then for the last peak here in this chunk, that's not going to be correct because I haven't seen the next peak yet. But if I do it here, it is going to be correct because I will see the next peak, unless it's very far away. If it's further away than the window size, then it doesn't work anymore. So the window size sets sort of a cap on how far you're able to look ahead or behind. And the same for computing a time to the previous peak. That actually would be valid if you do it here, but it would not be valid if you compute it here. So that's why it's discarded here and kept over here. You don't have to worry about this. The idea is that you just tell Strax, hey, this is the window I want to look ahead and behind me. And then Strax will take care of that the inputs arrive twice and that the outputs are properly discarded. That's what an overlap window plugin does. And we'll look into the implementation of how that works in a couple of weeks.
Something that is always confusing me. When you are in this compute function, the list of these peaks, this list of objects that you get, is it something, so you get, I think I checked, it's not just one, it's and this function is executed one by one. It's really an array. Does it mean that let's say the framework will provide these peaks in bunch? For example, chunk by chunk will give you all the peaks. This is a general question for all plugins.
Yes, so in a regular plugin, like for example here, peak positions, compute depends on peaks. So it will get chunks of peaks and it will see every peak once in one of these arrays. And then, only in overlap window plugins, you might see peaks twice, but you don't have to worry about that because Strax will take care of any removing any duplicates from the output.
But then when you, since you are returning a result out of these algorithms, then it's the framework that takes care of, let's say, how do you say, merging, concatenating the results chunk by chunk?
Yeah, so the way it works is that you can get these things in chunks of various durations. So if you run this in the online processing, you're going to get very small chunks of only a couple of seconds. If you run offline processing, you might get a chunk of half an hour because peaks are not that difficult to store. So they're not that large to store. So we store them in a large file, and then that one file will be the chunk. So yeah, indeed, when you do get array, see where my notebook is, then it will load the different chunks for this data. It might be that, well, it's certainly the case that peaks has different sized chunks than peak basics. Peak basics will likely have only one chunk, and peaks will have several. You can also see that here, right? So you see here, peak basics has, well, okay, it has 3 files, but peaks has, okay, none, but you have merges tools and peaklets, which have a much higher number of chunks. So all this concatenation is done behind the scenes.
Okay, thanks.
Okay. So other questions on like this overlap window plugin, what it does, and how to work with it. You can see here it's returning a dictionary, whereas previous plugins here returned an array. This is also just a syntactic sugar that you can return this dictionary, and then Strax will turn it into an array for you. There's one complication related to multi-output plugins, and we'll see that next time. So I would suggest, if you can, just return an array. That's easier, but returning a dictionary, well, the dictionary is easier, but okay, you'll see next week the complication that ensues.
One question on the calculation of the time to next peak, time to previous peak.
Yeah.
Is that exact syntax more efficient than just np.diff? You know, in terms of, which is, you know, it calculates the difference between adjacent elements and arrays.
Yeah, it's certainly less efficient. Well, I don't know if it's less efficient or not, but the point here is that I have a time and an end time, which are different. So I want to compute the difference between the end of one peak and the start of the next peak. And peaks have an extension, so that's why I couldn't use just np-diff peaks time here.
And then second thing, so time to next and time to previous are kind of the same thing, except maybe with a minus sign and a shift by 1. Would it be possible to save some computation cycles by, instead of overwriting, all but one of the array, maybe shift it by 1 and then just add 1 or 2 extra entries?
Yeah, that's a good idea. We actually are already copying it here. So we can probably NumPy roll it and then just compute the one extra element that we're missing. That's a good idea. Yeah, that would save a bit of computation. Yeah, good point. Also, it avoids duplicating this code, which is perhaps an even bigger point, that if this code was bugged somehow, now it's duplicated in 2 places. So maybe someday somebody finds out that this should have been -2. I don't think it is, but maybe, and forgets to update the other one, then that's going to be embarrassing. So when you get to your homework later, these are great things to be on the lookout for. Like, hey, why this looks like duplication? Why does that happen that way? Or could we do it more efficiently? Okay, let's move on to event processing. So event processing. Let's look at events. I can already see one. Okay, so it's an overlap window plugin again. Okay, we've seen that. I can already see some differences with respect to the other plugins. For example, here's something. It depends on these 2 things over here, but here I see 3 things in the compute method. Can somebody explain to me what's going on here? I think this was one of the study questions, or maybe in a slightly different context.
So there's the option to pass also as arguments the start and end, which will be then the start and end of the chunk, but does not necessarily to be included in this depends on.
Yes, yeah, that's right. So that explains these two arguments. These are optional things you can add to your compute method. So we talked about this chunking, and you will usually just get an array rather than this Strax chunk object, which you saw briefly last time. But if you actually want to know what were the start and end times of this chunk, not what's the first and the last data, but what is like the start and end of this chunks, because you also care about the bit of no data, then you can add these things. Okay, but that still doesn't explain why do I have one thing here but two things over here. How does that happen?
Can you explain? But I have not understood this start and end are options for this method. So you are requesting peaks within these two times, or?
So what happens is that Strax will look at how you wrote your compute method, and it will check if you have start and end there as arguments. If you do, then it will give you those arguments, and what it will give there will be the start and end corresponding to this array of peaks. That can be useful if you also care about when a period of no data. For example, it could be that there's no peaks for a while, but you may want to know that because you care about, for example, times where there is no peaks, then you want to emit something or do something. Then you can add these two things to your compute method to make use of that. So my question was here, why is there only one peaks here, but I have two dependencies? How does that work?
Peak basics and peak proximity represent the same data kind, so they get merged.
Exactly, right. So what's listed here in compute, those are always data kinds. So peak basics and peak proximity are of the data kind peak, so you'll get peaks as argument. You can see this even better in events basic. I think that was the study question directly. So you see here a compute loop, because it's a loop plugin. Here you have two things, event and peaks, with the dependencies, list events and three peak dependencies. So these three will be merged, so you get peaks, and then you'll get events, or in this case, one at a time, because you have a loop plugin. Very good. Okay, anybody had any questions on events, on how we find events in Strax?
Yeah, I have one.
Go ahead.
Yeah, I see this condition for triggers that the area has to be greater than trigger mean area, which I read is 100 photoelectrons in this moment, in this configuration. And so this is clear, yeah, okay. And then there is another request, so I was curious about this one. Why should be less equal than 7 trigger max competing thing? So less than 7 competing peaks, yeah.
Okay.
Yeah, I was curious about that.
Yeah, so for the triggers, these require that the area must be larger than 100, and there must be less than 7 larger or slightly smaller peaks nearby. Okay, so let's try to think of a situation where that would happen. So you have a peak, but there are like 7 or 8 sort of similar peaks next to it. Can you think of a situation in Xenon where this might happen?
Maybe the tail of a biggest 2, for example.
Bingo, that's it. So if you have a long electron tail after an S2, you have all of these little electrons or pile up of electrons. So then you get many of these events that you, if you wouldn't have this condition, then many of those would become events. And we saw this population in Xenon one time where you had like many fake events, which just consisted of junk basically. So this is one way to remove them, and then you can maybe so that would allow you, for example, to have a lower area threshold over here. And we dared to do that here because this is a very high level plugin. If you don't like this, then you just change it. You just set this to let's see, infinity, and then the constraint doesn't apply. And then you see if there's any interesting new events that you find.
Yeah, it's easy and fast to change if I want to play around with this. Okay.
Exactly. Yeah.
Okay.
Yeah, the reason we have it is so that we don't get events in a long electron tail. Because that was the idea. I never really checked this. I just put it in there.
No, it's clear. Yeah, I see. Thanks.
Yeah.
But what does this imply for the analysis? Isn't it just like introducing a sort of dead time? So yes. Somehow there was a cut in Xenon 1 ton for this that was as two tails. That for was sure. Then considered a sort of detector of time.
Yeah. Yeah, so what I'm doing here is I'm saying, hey, I'm going to have essentially a variable trigger threshold. I'm going to have a trigger threshold that is at least 100. So it's not going to go below 100. If you have a 50p thing, it will never trigger. But it might be that the threshold is sometimes higher. So if you want to compute the acceptance of that, then you will have to do that. Though note that in Xenon 1 ton, of course, we also essentially had a variable threshold. Only, we didn't. Right, so we didn't have maybe a variable threshold, but we had still a cut that this. So you have to compute it. It doesn't really matter whether you do it here or in a cut, except that if you do it here, you prevent it maybe from messing up other events that happen at the same time. So if you have like many of these, you have like a few of these happening and then a real event, in Xenon 1 ton, it would then get merged into one kind of huge bulky event that you would then maybe consider, yeah, should I keep it or not? And in this case, those things won't even get made into events. We had to do that in Xenon 1 ton because the trigger was super low level. You could never change the trigger threshold after you took the data. Whereas here, this is one of the last plugins that you run. So it is almost as easy as changing G1 or G2, which we'll certainly change.
Maybe not a question, more of a comment. Mm-hmm. The left and right extensions, at some point we should remember that we need to update those because assault the 1 ton defaults of 1 millisecond.
Yeah, that's right.
I don't remember exactly what the max drift length is. Diego probably would. It's like 1.3 milliseconds, I think. So we should figure out exactly what we want to update this to.
Yeah. Yeah, good point. It is actually one of the analysis tasks, just figuring out what should we use as event selection and what's the acceptance, how does it relate to the single electron train. And max drift time is, of course, also a consideration.
Yeah, at the very least, your trigger extension should be longer than your drift length.
For sure. Other questions on this? I think this comment is out of date, by the way. Yeah, it's really useful to have these comments around if you don't know if they're up to date, but okay. Right, so we have a few minutes left, so let's briefly look at event basics. Anybody have a question on that? Notice here that the data type isn't explicitly set. We have a function called infer D type, which makes the data type. And that's just because it's easier to specify algorithmically because I've got many repetitions here. Because, for example, there's the S1 index, the S2 index, alternative S1 index, alternative S2 index, etc. So rather than a huge list with many repetitions, we just make it in this function. Any questions on this?
Okay, this is one of the cases in which you have two data kind, and you say that the result will be the first. No, I don't remember.
Yeah, so the data kind, you can always specify it explicitly. That's never a bad thing to do. So you can just say data kind equals events. You can also specify the data type. Also never a bad thing to provide. Oh, event basics. Never a bad thing, but this is automatically inferred from this class name, and there's actually a function in Strax called camel to snake that does this conversion.
I think Matteo was more referring to the loop plugin that this is now a loop plugin instead of a regular plugin.
That is right, it is a loop plugin. So you get one event at a time, and you get all of the peaks that are inside that event. That is right, yeah.
I have a question. Can you hear me?
Yeah.
So what exactly does the data kind do? I know the provides decides what's get in, and then the provides decides what gets out. But what does the data kind do?
Yes. So the data kind is basically the color in this graph. So the data kind just sets which data types can you load and merge together. So peak basics and peaks were the same data kind, so I could do this. But if I try this with peaks and event basics, then this will give me an error and say, hey, okay, well, this gives me a different error. Event basics gives me the error, say, hey, I can't merge these kinds. That's all it does essentially. It just says what kind it is and whether you can merge it and whether you will get it merged in Strax.
So basically, it's kind of like a flag for Strax to determine like faster whether it can be merged or not, right? So it does not have some technical function in the class you are actually defining.
Yeah, I'm not sure how else you would determine whether things could be merged or not. You could try to check whether they're equally long, but that might not mean that they're merged. Maybe it just happens to be for one chunk that they're equally long and the next chunk they're not. So
yeah, that's actually my guess for the arrow you just showed before you tell me this. So
this one.
Yeah.
Or you mean the other area? I had another error when I did this, but that was just a typo.
Oh no, the actual correct arrow. I mean, maybe that's just some kind of except, and then you redefine the arrow message. But yeah, anyway, it doesn't matter.
Yeah,
no, I
so
understand.
Yeah,
Thanks.
This means that the data kind is different, and then you can't merge it. Okay.
Yep.
Other questions on event basics?
So maybe one other question. I think this option that is set above the like force the main S1 before the alt S1 before the main S1, or the other way around. Mm-hmm. Can you force a plugin to do something else, like do another option in a subsequent plugin?
No. What you could do is you could, in your compute, check if an option has a certain value, and if it has a different value, crash. That you could do. But in principle, an option is it's set by the user, and you don't have control as a plugin over what value an option has. You can set a default, but it's up to the user to set the option.
Okay, thanks.
And this default is the default if the context does not define it?
Yes, exactly. So if you look here, I did here show config. Let's do it for event basics. So here we have force main before alt. The default is false. The current value is omitted, right? So if I can check here in config, it's not in here. So then the default is false is used. Yes. But it is tracked in the lineage. So if I get the lineage for this guy, basics lineage, right? So I have, it is tracked that it is false. It doesn't say, oh yeah, it was produced with some options, because the defaults might change at some point. And that's also why we have these options explicitly declared. Okay, in view of the time, I think most of the other plugins are, at least Strax-wise, relatively straightforward. They do some kind of very intricate corrections, but that's just loading a map, basically. Does anybody have some particular question on these things?
Can I ask a question about one of the corrections, about the field distortion correction? About the Z correction in particular. I think it's just applying simply Pythagorean theorem, Y.
So that's here, right? That's what you mean.
Exactly, yes.
Yeah, so this corrected z is the observed z squared minus delta r squared. Okay, that's a good question. I think it's in one of the field distortion notes, but perhaps one of the experts is here who can explain.
I was actually looking into this yesterday, but I have not a proper answer right now. I was struggling with it as well. I was looking through Jinkang's note, I think.
Mm-hmm.
So I guess it makes sense that when you stretch on R, the z coordinate might change, but at some point I lost it.
So in principle, since you're pushing inwards, it means that the electron is traveling more, and so the delta r will translate in delta time, and so you are pushing downwards, pushing down the event, and this is due to the fact that it's simply moving radially. So this is why you're correcting. Then why exactly there is Pythagorean theorem? This is simply because this is a simplification. Because
okay.
the actual path is much less perfect.
Yes, this is what I imagined, and so I was wondering how good this approximation is.
I mean, in principle, you don't really know the real path, so I think it's quite a good approximation. And the difference in drift time is not that huge.
Yeah, thanks, Francesco. That's clear. So this z ops is basically more like a path length than really a z position. Yeah, so that's how you get it from the drift time. Okay. Any other questions on these last plugins?
Yeah, I'm still quite confused about this option thing. So as in for analysis, right, I'll probably be using like crunching on DALI, and then I wouldn't be changing the source code, right? So how do I change the values in these options?
So you can do that here. So for example, we had event basics. We looked at the allow force main before alt option. So suppose I want to load event basics with a different value of force main before alt, and I can just do get array id big basics config equals true, and now Strax will get that for me. Also do false. That's how it works. Oh, well, peak basics, of course, that doesn't take that option.
Event.
Yeah, event basics is better. Yeah. Okay, and true is the thing. Now I can see it worked because it took a little longer. Yeah, so this is how you change it. If you want to do it permanently, you can also do it like this with set config like this. And this is all in the Strax tutorial. So if you want to see how it's done, it's explained there.
Thanks.
Okay, then I guess we're at our time. So let me just briefly mention next week. So next week we will look at low-level processing. So as today we'll have some code to read. So there's peaklet processing where you'll see basically what comes below this graph. You read about the different clustering and how peaks are merged together. I'd recommend that you skip like some of the hairy details of these peaklet processing functions, unless you're one of the people who currently are intending to work on that. And there's a node you could review first. And we'll read pulse processing, which is really the lowest level pulse processing algorithm. I didn't put the DAQ reader on this list. If you're interested in that, for example, for working on small TPCs, then I think after this you'll be well prepared to look at that. But there's of course a few extra complications that won't be relevant to most people here. And just as a reminder, please sign up for a Strax function. Then we can see where I got the spreadsheet over here. I won't sign myself up because I've read all these functions already. Just pick a difficulty level that you like. sign yourself up, and then I hope we can have some interesting pull requests or presentations next week or the week after. That's all. See you guys next week then. Same time, same place.
Thanks, Jelle. Bye.
Thanks.
Thanks.
Bravo.
Bye.
Thanks.
Bye.
Bye.
Thanks. Bye.